Hi everyone, and welcome to day 17 in our Rust adventure. This is Advent of Rust, and we're building together a web API in Rust. Today we are going to see how we can take a payload as JSON and insert it into our app state. So let's dive into the code. So yesterday we added the post pizza endpoint to take a pizza as a JSON and do nothing actually. So now today what we need to do is to add this pizza into our state. So first we need to have access to our state. So make sure you add this as a parameter. Now we need a pizza, and ActixWeb would have access to the state via the data parameter. Note that the pizza is not directly a pizza, is a JSON type of a pizza, and this is a struct managed by Actix. So to have access to the pizza, we need to do something. So the pizza will be actually pizza.0. Why we want to do that is pizza is a JSON of pizza, and the first field, which is unnamed, so that's why we're going to use 0, is the actual pizza. So to retrieve this type, we just need to do pizza. And you can notice that in Rust, there you can have multiple times the exact same name. So it could be new pizza, but you can use the actual name. So if we want to use pizza again, that's totally fine. So now we have our pizza. So maybe what we want to do is to call data dot, we need a new function, let's say add pizza, and we're going to pass our pizza. And maybe the JSON would be, instead of the pizza that we've just passed, maybe we want to get the list of pizza as well. So we add a pizza and we retrieve a new list of pizza, which will contain a new pizza. So if we have an empty array, we add a pizza, we should be able to retrieve an array with one item. So let's go ahead and add this add pizza function in our app state. We are going to do function add pizza. Don't forget the self. We're going to pass a pizza. We are not going to return anything for now. And what we can do is to self.pizza.push to add this item to an array and our pizza. Note that in Rust, everything by default is immutable. So self cannot be mutated, and that's the error here. Self.pizza, we need it to be mutable. So to do that, what we can do is we can specify to the Rust compiler, hey, self is going to be in a mutable state. So now I have access not only to the pizza vector, but now I have access to modify it. So if you don't need it, don't use it. But obviously here we need to mutate our pizza. So that's cool. Now we can go back to our pizza service. And if you see, now we have an issue, because now we are trying to mutate our vector of pizza into a thread, into a request. And that's not okay, because remember, if we have like 10 requests coming at the same time, and 10 requests are going to update at the same time the exact same data structure, that can lead to a data race and to data corruption. And this is not thread safe. And one cool feature of Rust is at compile time, you know that something is wrong. So compared to another language, when you can compile it or not, and you can run it, you have an exception at runtime. Here, Rust guarantees you that that's not going to happen because it fails to compile. So it might be a bit annoying at first, but then it's so much better to know that at compile time, so you won't be able to ship invalid project or invalid binary. So here we need to fix it at compile time, which is great. So let's go ahead and fix it. So here, vector of pizza is not thread safe. It means that we cannot guarantee that only one can have access, only one thread can have access to this data structure, and this is a big issue. Fortunately, Rust has a built-in feature for that, which is called Mutex. Let's import it. And Mutex comes from the std sync library, which seems great because we want to synchronize access to the vector of pizza. So yeah, Mutex does take almost any type as a parameter. So here it's going to be a vector of pizza, but you could protect an int, a string. You can protect a lot of different type. Obviously, we will need to modify the new function. Mutex come with a nice new function, so you can just use new, and tada, you have a type protected by a mutex. So what is exactly a mutex? Mutex will allow you to have a lock on your data structure. So everything that concerns a vector of pizza, now we have a lock around it. So if you want to modify it, you will need to acquire that lock. So if you get the lock, that's fine. You can modify it because no one can acquire the lock once you have it. Once you're done, you release the lock, and someone else, another thread, another request, can take the lock again and modify it. So this is exactly what we need to do here. So let's go ahead and modify the get list pizza. Now we're not able to retrieve the self pizza anymore because we need to acquire the lock. So this is what we're going to do with self.pizza.lock. This is returning a result, so we need to match it. It's either I succeed in receiving the lock or I fail. So let's match. And once again, it's an enum, so we need to list the two different cases. Either it's OK and I have access to the inner type, and we will do something, or I have an error, and maybe for this example, I can return like an empty vector. If I don't succeed in getting the lock, maybe returning an empty array that is fine. So let's go ahead and return an empty array. And we can use a default, for instance. Default, remember, we saw that last week, I guess. It's taking the default constructor of the type. So it's going to take the default constructor of pizza and the default constructor of vector of pizza. And vector of pizza is empty for default behavior. And for pizza here, so we got the lock, we got the access to the vector of pizza. So we need to do to vector. And actually, we are not able to return the reference to the vector of pizza anymore because this reference is not safe because if someone is modifying outside of the lock, this reference might not exist anymore. So we cannot do that anymore. What we need to do is returning the actual vector of pizza. So a duplicate copy of this vector of pizza. And to do that, we need to be able to clone our pizza, which is not possible right now. The compiler is telling us that pizza clone must be satisfied. So let's go to the pizza type, and we can add the clone instruction. By doing that, now we are able to acquire the lock, read the pizza vector, and actually returning as a new vector. And if we don't succeed in acquiring the lock, we can return a default empty vector of pizza. Let's do the same for pizza. We need the exact same stuff. We need to acquire the lock. If we have access to the pizza, we need maybe to push the pizza to this, let me call it new pizza because it's going to be more clear. So we have access to this pizza, we can push it. And if we don't have access to it, maybe do nothing for now. Here we can see that pizza needs to be mutable. So you can do mute here and we can have access to it. Do we need this? Actually, we don't because it's not the self which is mutable, but it's the mutex, which is the nested type within the mutex, which is mutable. So now you can do that. So we acquire the lock. If we get the lock, we push the pizza. If not, for now, we're not doing anything. So let's go back to the pizza service. And now we can add the pizza and we can get the list of pizza. So let's go ahead and try to run it. So if I run the exact same curl command, so a post request to /pizza, the data is a JSON representation of my pizza. Don't forget the content type as a JSON. So this should add the pizza to the vector and return it. This is great. Our pizza has been added. So let me try to add a new one. So the exact same pizza, but this time the price would be 100. And this time you see that this is working. We have access to 2 different pizza, one with price 10, one with price 100. So I know this session was a bit harder than usual because we talked about mutability, immutability, the mutex, but we will talk a bit more about that tomorrow. So thank you so much and have a good day.